I'm Dustin Jenkins. I am the Senior Analytical Chemist and Laboratory Supervisor here at the Materials Characterization Lab at Smithers-Rapra. So today I'm introducing the chromatography lab here at Smithers-Rapra, and we're going to be specifically looking at GCMS and HPLC and what kinds of products they provide to our clients. So GCMS is gas chromatography mass spectrometry. HPLC is high performance liquid chromatography. Both of these, any kind of chromatography, are separation methods because in the real world we rarely find that we're dealing with pure compounds. And so chromatography is a physical technique that allows those compounds to be separated efficiently so that they can be identified and quantified. With our setup, HPLC has associated with it a PDA and an RID detector. The GCMS has, of course, a mass spectrometer as its detector. Now, with the detectors with the HPLC, this is more analogous to identification of a person based upon their mugshot. You know, you can narrow down two different people via mugshot, but there are a lot of people out there who look very similar. If you want to get a more precise identification, that's where mass spectrometry comes into play, because every molecule has a specific mass spectra. Mass spectrometry is analogous to the identification of a person via their DNA. With UV-Vis or RID, two molecules that are very similar in structure will look almost identical. Therefore, if you're looking to discriminate between similar molecules, mass spectrometry is a more powerful technique for identification. GCMS is more applicable to highly volatile compounds. Its carrier medium is gas, generally helium. Therefore, it's more suited for the analysis of volatile compounds such as plasticizers or low boiling antioxidants and antiozonants. So this is our GCMS, gas chromatograph mass spectrometer, and this allows us to separate complex mixtures of volatile compounds. And so by using a silica-filled column and a mobile medium, which is generally helium, we can separate mixtures of compounds out based upon their volatility. And so once those compounds are separated within the GC, they then are analyzed by the mass spectrometer. And the mass spectrometer will give us the unique mass spectrum of every compound. And so therefore we can pinpoint with exact certainty what compounds we have, and we can also quantitate within a very high degree of precision. The HPLC is more applicable to less volatile compounds. So those that have higher boiling points that cannot be analyzed via GCMS, that's when HPLC is used. So this is our HPLC. It is equipped with a photodiode array detector as well as a refractive index detector. And we use this instrument primarily for identification and quantitation of non-volatile compounds, especially in rubber extracts. And what we have here is a number of solvents, and the solvents essentially run through these lines into the instrument, which then pick up the sample and run that sample through a stationary phase in what's called a column, which allows the different components of that mixture to be separated out based upon intermolecular forces. And then once each component comes off of the column, it then enters a PDA cell or a refractive index detector, and then the signal is picked up by the software in the computer. So right now, the sample has just been injected, and we're monitoring the signal of the instrument. And if we look, eventually we'll be able to see each compound come off, and it will simply appear as a peak in the instrument response. So as you can see, the PDA detector coupled with the RID detector with the HPLC provides a very powerful tool for meeting the needs of our clients. With both GCMS and HPLC, we're able to give our clients very specific data related to such things as formula reconstructions, volatile organic content. And so we're able to take samples and, number one, identify and quantify various small molecules that are within those samples. We're also able to look for compounds that shouldn't be present. So these techniques allow us to provide client products in a variety of fields. We use them in formula reconstructions whenever we're breaking down rubber or plastic formulations. We use them for headspace analysis. GCMS is particularly powerful to analyze volatile organic content. The chromatographic techniques also allow us to provide highly accurate raw materials assay for anything you can think of, any raw material, small molecule. We also use these techniques for failure analysis. So we can take a particular material that has undergone some kind of chemical or physical failure, and we can analyze, say, its surface or its interior, and we can break it down chemically to try to determine why that material failed. We enjoy sitting down with our clients and figuring out a specific approach to their unique problem. We have a large number of people on staff here who have a variety of expertise and who care about getting our clients the exact product that they're looking for. We invest in experts and we invest in high-end instrumentation to achieve that goal.